Hey, welcome back. We're going to take a look at some problems we have in section 3.5. If you're looking at the supplemental video that was uploaded for 3.3, remember that's also intended to show the same techniques that are going to be included for section 3.4. Even though in 3.4 they emphasize the process of foiling, they may use the multiplication box to do the most of those same type of questions that were shown before. The objective of section 3.5 is to address the work that we do with exponents. So we're going to go ahead and take a look at how we work specifically with negative exponents. So let's take a look at how we address those. So in question 1, we're asked to simplify the following expression. Now, sometimes when we're asked to simplify the expression, sometimes they're going to want a number at the end, but the rules I'm going to really focus on are how we work with the exponents of this. Some of these things can be done with a calculator quite quickly, but when you work with variables and have to play with their exponents, those are not going to be easily done. In fact, they're not going to be done in calculators. You have to know the rules. So let's take a look at one. And number 1 in section 3.5 is 5 to the negative 3. As I mentioned in class, if you have anything raised to a negative exponent, the objective is to get rid of the negative on the exponent and then carry it out. Sometimes they can't be done right away. We may have to do a little work first, but this video will hopefully refine some of the techniques that I believe are going to be easiest. And in fact, some of the techniques for this will be a little different than what I showed in class even yesterday. All right, so it's Monday. I'm filming this the day after our class. So I'm going to take the 5 to the negative 3 over 1. I'm going to box this. Like I talked about in class yesterday, we box what we move. And it's our intent to move that to the denominator so that I can write this as 1 over 5 to the third. Oh. So, yeah, you can see that. And 5 to the third, that's equal to 1 over 125. And that's going to be the final answer for question 1. So, in a few classes yesterday, I showed this. I didn't show it carried out to this step. So, hopefully this will help to correct that lack of follow-through that I had in class yesterday. Let's take a look at question 2 now. Here we have 2 times x to the negative 3. And here goes an example where we have a negative exponent on a variable where a calculator won't be of much help. So what you want to keep in mind is, what is the exponent acting on? And a lot of times students will take this whole thing and move it, but in this case the exponent is only on the x. Therefore, when I need to move things down to the denominator, it's only x to the minus 3 that I'm going to move, but I'm going to make it x to the third. And that's how I write this, using only positive exponents. So when you're looking at your homework in section 3.5, you're going to see the directions for question 2 in that section will state that they want this answer written with only positive exponents. All right, so what I'm going to do next is I'm going to take a look at number 3, and I go in order here. I have negative 1 over 6, and that's raised to the negative 3. So what I'm going to do is I'm just going to try to get rid of the parentheses first. I was telling students about flipping the problem yesterday, but I didn't like the success that had, so I'm going to have students just kind of distribute this first according to the rules we have for this that I had gone over in section 3.1. So we're going to write this as negative 1 to the negative 3 over 6 to the negative 3. That negative is not going to go anywhere. So if I take negative 1 to the negative 3 and I take negative 6 to the negative 3 and I swap these things because of the negatives on the exponents, then it'll give me 6 to the third over 1 to the third. 6 to the third is 216. Don't take my word for it, do it on a calculator. That'll be 1, and our final answer will be 216. Okay, that's question 3. We'll go up to question 4 now. And question 4 is going to read, simplify the following, make sure that it uses only positive exponents. This is going to be 1 over p to the minus 3. So in this question, the only thing we can move is p to the minus 3. I'm going to box that. That's going to give me p to the 3 over 1. Or, because it's just a 1 below, I'm going to write that as p to the 3, and that'll be my final answer to question 4. Let's take a look at question 5. I think question 5 I may have gone over in just one class. And it says to simplify the following expression, which means it doesn't want this necessarily containing exponents. Now, a calculator will do this for you straight out, but I feel this is a good example to kind of look at to see how it's carried through. So, we have 4 to the negative 3 plus 4 to the negative 2. What I'm going to do is I'm going to go ahead and write each one of these over a fraction. I'll move this up here a little bit. And I'm going to box this. I'm going to box this. So when I rewrite this over here, 4 to the negative 3 over 1 is going to be equal to 1 over 4 to the third. Plus 4 to the negative 2 over 1 is going to be equal to 1 over 4 squared. If I carry the math of that out a little more, in fact, I'll do this below here. 4 to the negative 3, or 4 to the third, is equal to 1 over 64. 1 over 4 squared, that's equal to 1 over 16. Now, you could take this on your calculator and add this up right away, and you can check my mental math against this, but if my mental math is correct, I believe, and you can do this on a calculator, that your final answer is going to be 5 over 64. Now, if you wanted to type in this original problem as it was written, I would dare say as long as you type it in correctly, your calculator will probably give you the decimal equivalent of this that you would need to convert, but you should get 5 over 64 for this. Still, the purpose of this is to reinforce how you get rid of the negatives on the exponents, and that's why I'm showing this a little bit of the long way. Okay, let's take a look at number 6 now. So number 6 reads as r times, or over, r to the negative 9 times r to the negative 9. Now here they don't show the multiplication. I'm showing it. Just kind of reinforce this idea. Now if you were to multiply these, you could get r to the negative 18 and then move it up. So that's one technique. But what I'm going to go ahead and do is I'm going to go ahead and box these two things. And I'm just going to move this as r times r to the 9th times r to the 9th. And that's going to be over 1. And when I put that all together, that'll give me r, 1 plus 9 plus 9, r to the 19th for my final answer for question 6. Let's go ahead and take a look at question 7. I did question 7 in a few classes yesterday, but I did not do it everywhere. So question 7 reads, simplify the following expression, write the result using only positive exponents. Now there's a couple ways that you could do this, and if you have a way that works for you successfully all the time, keep doing it. Negative 20, a to the third, b, divided by 4, a, b to the fourth. So I'll show this probably a couple different ways because I know, again, everyone may have a different technique they may have learned elsewhere. And when it comes to working with exponents, there are a lot of techniques that you can apply or different paths to a solution for this. But I'm going to try to stick to the rules that we know here. So let me kind of carry this out with the rules that we learned about regarding division. We have negative 20 divided by 4. So we have negative 20 divided by 4 times a to the third divided by a, that's a 1 there, just like there's a 1 for b here. That's a to the 3 minus 1 times. Then we have b to the 1 minus b, or divided by b to the fourth, b to the 1 minus 4. So negative 20 divided by 4, that's going to give me negative 5. A to the 3 minus 1 is going to be a to the second. B to the 1 minus 4, that's going to give me b to the negative 3. So I get that for an answer here. But in this case here, I probably want to move this down so I get rid of the negative exponents there. And when all is said and done, that's going to give me negative 5 a to the second over b to the third. And now I have my final answer written with nothing but positive exponents. Let's go on to try some of the questions here. And I'm going to, again, show some different techniques than what I looked at in class here. Okay. So this is going to be question 8, and the way question 8 is written, I'll just do the work for these below. I'll keep things a little more concise, at least for the first part. Is I have the question negative 2, 5, or sorry, x to the 5th, y to the minus 4, times 4x to the minus 2, y to the second. So the rule here is we're going to take these exponents and add them. So let's just kind of put our like term, not like terms, but the variables that are in common together, because this is one term and this is one term. So we're going to put like things together. Negative 2 times 4 we have x to the 5th times x to the minus 2. Then we have y to the minus 4 times y to the 2nd. And at this point is, we should be adding these, but things are negative. So on your calculators, you want to think about how this is done. So if integer rules confuse you, just try to think about what the process here. Okay, so negative 2 times 4 is going to be negative 8. So this is going to be 5. Remember, we add these. So this is like x 5 plus, what are we adding? Negative 2. You can type that in the calculator, be sure to get an answer, unless you're good with your integer rules. This is going to be negative 4, again, plus 2. So once we have that work done, this will give me 8, negative 8, x to the 3rd, y to the negative 2. That should be like our final answer to that, except we have a negative here. So I'm going to put that over 1. I'm going to box my y to the minus 2. And our final result for this should be negative 8 x to the 3rd divided by y squared. And that is one path doing question 8. I think there are other ways to do that question too, but that is one method of solution. Let's go ahead and take a look now at question 9 and see how question 9 is done. And the question reads, to simplify the expression, assume that all the bases are not equal to 0. So this is going to be a minus 7, b to the 4th. This is raised to the negative 4. So what I would encourage you to do, since we're going to have to multiply each of these exponents together, is just multiply it through so we don't have the parentheses anymore. So a to the negative 7 times negative 4, that would be a to the 28th. b to the 4 times b to the negative 4, that's going to give me b to the negative 16. Now that would be my final answer, except that I have to write all of these with positive exponents. So if I put that over 1 and I box my b because it's negative, that'll give me a to the 28th over b to the 16th. So I think it's easier to just kind of distribute this through rather than trying to flip like I was showing in class. I think this method will be easier for students to understand and a little more consistent with what we learned earlier. Okay, I showed 10 in class. I showed that in every class, so but I'll go ahead and show this again, just in case people need the additional practice. So it says to simplify the expression using only positive exponents. So you have 2ab to the negative 2 divided by 2 to the negative 1, a to the negative 6, b to the 5th. So what I want to do is I want to figure out what are the things I need to move. B to the negative 2, 2 to the negative 1, a to the negative 6. I'm going to write the things first that are staying put. 2 is staying put, a is staying put, b to the 5th is staying put. I'm going to move each of the other things. B to the negative 2 becomes b squared below. Just put a line through it. Not obliterate it, just put a line through it. Next, 2 to the negative 1 is just going to become 2. I could put it to the 1, but that doesn't serve any particular purpose. A to the minus 6 becomes a to the 6th here. Now everything has a positive exponent, but I do need to clean this up a little bit. 2 times 2 is 4. A, because that's the 1, times a to the 6th is a to the 7th. And b to the 5th times b to the 2nd is b to the 7th. And that's going to be the final answer we have for question 10. Let's take a look now at question 11. Question number 11 reads, simplify the following expression, and this is going to be kind of a big expression. A to the minus 5 times b divided by a, b to the 5th, and on the outside it's going to be negative 2. Now one of the techniques I showed in class yesterday was to flip the thing to get rid of the negative on the outside. I would recommend instead just multiplying everything through by negative 2. And then we'll worry about taking care of the negatives from there. At least it gets rid of the parentheses in the very first step. So this would be negative 5 times negative 2, giving me a to the 10th. This is a 1. This is a 1. So 1 times negative 2 will give me b to the negative 2. 1 times negative 2 gives me a to the negative 2. B to the 5th to the negative 2 is b to the negative 10. Going from this point forward, we no longer have parentheses. We just got a box we want to move, which is going to be 3 things. Here, here, here. So what's going to be left once I'm done here? A to the 10th will be on top. B to the minus 2 is going to move to the bottom as b to the second. A to the minus 2 is going to move on top to become a to the second. And then b to the negative 10 is going to be moved on top to become b to the positive 10. So we're going to clean this up in two stages now. First, we're going to go ahead and a to the 10th times a to the second will be a to the 12th times b to the 10 over b to the second. So we just kind of combine what we can on each side. And then we have b to the 10th divided by b to the second, or 10 minus 2 will give me a to the 12th, 10 minus 2, b to the 8th. And that's going to be the final answer for question 11. Now again, if you want to try any of these any time, you're certainly welcome to. Again, you're going to learn a lot more from the mistakes that you make with these than by simply seeing them all worked out yourself. So please take risks and make mistakes. If you're watching this at home, no one's going to know if you get it wrong. So the question here says to simplify the expression and write the result using only positive exponents and assume that the bases are not equal to 0. So this would be a squared b to the negative 5 to the negative 5 divided by 3a to the second b to the negative 1 to the negative 2. Now I showed this in a couple classes yesterday, but not everywhere. So I want to make sure everyone sees this. So what I'm going to do is I'm going to go ahead and distribute the exponent on the top. I'll distribute the exponent on the bottom, and then we'll move things around from there. 2 times negative 5 gives me a to the negative 10. Negative 5 times negative 5 gives me b to the 25th. We have 3 to the negative 2, so that's going to be 3 to the negative 2. I'm just going to leave it like that. 2 times negative 2 gives me a to the negative 4. B to the negative 1 to the negative 2 gives me b to the second. So from here I have to decide, okay, what am I going to move? I'm going to move this, I'm moving this, I'm moving this. So let me put that down a little bit, so I'm going to continue that down here. So I have b to the 25th divided by b to the second. A to the negative 10 becomes a to the 10th. 3 to the negative, down here. Yeah, so I caught my mistake this time. 3 to the negative 2 becomes 3 squared. A to the negative 4 becomes a to the 4th. Okay, so I move things around. I want to make sure I move it correctly. It looks okay. So 3 squared, 9. A to the 4th, b to the 25th. That's going to be divided by a to the 10th, b to the second. Now, if you follow normal subtraction rules for this, for the exponents, that'll give me 9. A to the 4 minus 10, that gives me a to the negative 6. And then 25 minus 2 will give me b to the 23rd. Well, this question is almost being done cleaned up, except if I put that over 1, I want to try to move that a to the minus 6 below. So that's going to be 9 b to the 23 over a to the 6 below. And my answer is now written without any negative exponents. Okay. Scientific notation, there should be information in the video on that. Since scientific notation is commonly done, I'm not going to provide any videos on that. It's fairly, it's a much more straightforward concept than other things, so that's going to conclude my video for section 3.5.